Hi guys, Mrs. Jaqua. It's Core 4, Unit 8. It's April 29th and we're still looking at polar coordinates, vectors, and complex numbers. Today we're going to be going over graphs, polar graphs. Kind of like polar bears, but different. Just kidding, they're nothing like polar bears. Okay, so remember you can push pause when you need to write down better notes, but remember all this stuff is also built out in Schoology. This is to try to help you. Oh, did you get it? I think it's funny. Arr. Okay. Quarter ends May 15th for seniors. It's coming. Okay, so this is what we're going to be looking at. The difference of these two. X comma y versus r comma theta. R being the radius or the distance away from the origin, and theta being this angle. Angle from the initial side. All right, here we go. I think I gotta get this situated so it's well. So we're gonna graph from each point. I don't have a grid on here, so that way I can just kind of grid it out. So this is my initial side, and what we need to do is we first need to determine what my theta is. My theta is pi halves, so I'm going to go up pi halves. And that is where our point will lie on. However, we're at -1. So instead of going up to +1, this would be 1. By the way, that would be 1 comma pi halves. We need to go -1, so we're actually going to come down here, and we're going to come here. Boop! There's my point. And this is -1 comma pi halves. Takes a little while to get used to it. I think it's fun. I don't know, I like doing things weird, so that's why I think it's fun. So let's create ourselves our little graph. We're working on B now, not A and not C. So remember, this is where we start our angle from, and we're going to go 240 degrees, which is 60 degrees beyond 180. So that's 240. And then we're going to go ahead and take our point from 2.5. So this is 1, 2, 3, so right in the middle. So then that would be 2.5 comma 400, not 400, that's crazy, 240 degrees. Pause and digest. All right, so this last one, let's do our super cool grid that just helps me. I like my grid. So we're going to go -5 pi 6, which is right there. Close enough anyway. -5 pi 6. And then the next step that we need to do is we need to go 4 on that angle. 1, 2, 3, 4. So right there is 4 comma -5 pi 6. Sweet. Okay, so now I just provided a grid for you. Okay, so -7 pi 6 is this angle right there. I know you really can't see it, but that's okay. So that's -7 pi 6. And then we're going to do our doopers, 1.5. So there's my inner circle, that's 1. This is 2. So my 0.5 is going to be right in the middle. Whoop. So that's going to be 1.5 comma -7 pi 6. Super cool. That green was hard to see. So we're done with that one. Let's do our other one. Let's use green for the angle. So -135 is here. That's -135. Okay, so if we go 2 units out, 1, 2, But we don't want 2, we want -2, so we've got to come over here. So we're going to extend our super cool line. So it's actually this point here. That's -2, comma, -135. It's just kind of cool. I like it. It takes a little practice to get used to. So do the practicing. Okay, so if we're to find 240, and 5. 1, 2, 3, 4, 5. Right there. Okay, so how else can I get to that point? We can go 240 to that point. Well, what if I go backwards to that point? That would be, I don't know, is it -120? So then this would also be 5, comma, -120. Okay, well, what if we expanded this line and then we went backwards? So we had -5 on the 60-degree angle. Well, we can also go backwards, which would be -5 on the -300. Okay, so if I'm at, it's just got all clustered up. So if I go 300 degrees, but then I go back 5, 1, 2, 3, 4, 5, then I would also show there. So that would be -5, comma, -300 degrees. It's just kind of cool. So we first find where the angle is, then we add 180 to it, and then we rotate it from forward and backwards. So let's go work on the other one. Now pi 6 is the same as 30 degrees, so let's identify our 30 degrees. So this is pi 6. What's pi 6 counter spot? This is 7 pi 6. This is also, if we go backwards to that one, this is -11 pi 6. And this one over here, if we came backwards to it, that's -5 pi 6. So those are all the angle parts. And where we want to get to is we want to get to this number 2 spot right there. So how do I get to that 2? Well, I could do 2 and pi 6. I can come to it from backwards. So I can come to it from 2 and -11 pi 6. I didn't get the 11 in there. Now I have the 11 pi 6. And then the other route is by getting to its other side of the angle and then going -2. So -2 from 7 pi 6 and -2 from -5 pi 6. I don't know, guys. I just think that's cool. Don't ask me why. I just do. Now this one is pretty awesome. Let's graph that. You ready? Here's one angle out, 2 lines out, 3 lines out. I'm going to have to get a different color. Let's go for green. Okay, you ready for the big reveal? Poof! That's r equals 3. We're in a polar coordinate system instead of a rectangular one. Cartesian, this is polar. Let's go to the next one. It's going to be similar. Oh, shoot. I didn't do 2 of them. So I'm going to have to delete what I have here, which usually I have double, but I don't have double on this one. So let's cross off that one. Now let's look at this one. So where's 2 pi thirds? 2 pi thirds is right here. But you have to remember that we can have negative points on our line, right? Like we could go -4 and then 2 pi thirds, so we also have to include this. Okay, good. So that's a good digest. It's good digest. Now, if we want to decide how far 2 points are on a graph when they're in polar coordinates, then this is a really cool formula for it. So let's go practice that formula. Okay, so I'm given 2 points, and you can push pause and read it. Let's sketch the graph of the situation. I'm going to go to 150 degrees, which is over here, and out 8. So 1, 2, 3, 4, 5, 6, 7, 8. So that was my red one. Let's do a blue one. Let's go to 65 degrees and only 3 out. 1, 2, 3. So then what we want to know is we want to know what is that distance. Sweet! So you just fill in the holes. You know we have a squared, plus, we have a squared, minus, we have cosine, parentheses. Let's fill in our holes. Let's go for the red dude first. So it's going to be 8 squared. Oh, I forgot this part too. This will be 8. And then, oops, we forgot the minus part. 150. Okay, let's put in our blues. So blue. Okay, so that's 3 squared. These are times. And then this is 65. All you have to do is go use your super cool calculator. So this is 64 plus 9 minus 2448 cosine 85. Oops, that matters. Negative 85. So let's go to a cool calculator. You ready? This one's a cool calculator. I have the wrong spot. So we're going to do square root. Square root 64 plus 9 minus 48 cosine. We need to make sure our calculator is in the right format, and then we need to put it in degrees. Cosine negative 85. Oh, we need to change our calculator. X equals. Alright, I switched my calculator out from what I could do, and so that's why I'm having issues. Let's go back to just normal. New blank graph. Square root. Square root 64 plus 9 minus 48 cosine negative 85. So the distance is approximately 10, well, it's approximately 11. Let's put approximately 11 miles. So let's go back so you can see that I wrote 11 miles. Alrighty, there we go. Which is good because then you could see me figure out how to set up Desmos.com. Okay, we're going to need this chart, so I've provided it over here as well for when we need it. Okay, so if we want to graph each equation, I'm going to get rid of that sucker. We're going to use our chart to do it. So Sine, we're going to focus on the sine of theta. So let's do sine. We're going to do 3 parts, and then we're going to do a negative sine. I could just do negative sine. I don't need to do that part. So let's come over here and figure this stuff out. The sine of 0 is 0. The sine of pi 6 is 1/2. I need to change colors. Sine of pi thirds is square root 3/2. The sine of pi halves is 1. Sine of 2 pi thirds is square root 3/2. The sine of pi 6, let's come over here. Those are my sines. Sine of pi 6 is 1/2. Pi is going to be 0. 7 pi 6 is negative 1/2. And then negative square root of 3/2. And then we've got negative 1. And then we have negative square root 3. Oh, wait. Where's a 1? Square root 3/2 again. And then we have 1/2, negative 1/2. And then we have 0. So carefully watch how I plot these points. 0, 0 is right here. Pi 6, 1/2. I'm going to go on my pi 6 and, oh shoot. Let's make these, the biggest number is 1, so let's make this point right here. Let's make this 1, 0. So then in other words, we're going to go over pi 6 and 1/2. So 1/2 is going to be here. Okay, and then we're going to go square root 3/2. And square root 3/2 is, I think it's 0.8. Where is it? .86. We'll put 87. So the square root pi here, we're gonna go 0.8. It's about here. And then pi halves and 1. And then the other side's gonna follow. And then, so now we're pi to 0, we're back where we started. Then let's do these green ones. If I have 7 pi 6 and negative 1/2, so here's 7 pi 6, but negative 1/2, so I'm going to end up on that dot. And we're just going to redo these dots. So that would be my graph. It's kind of cool. So what I want to do is let's go over to Desmos.com and let's show you what we have. I'm going to come to graphs and I'm going to go where I find a polar graph. And then I'm going to delete stuff. So let's just open the graph. Let's delete stuff because it's too much stuff. So what did we have? We had negative sign. Oh, we had negative sign. I forgot to switch the sign. Darn it. Negative sign. So my graph actually belongs at the bottom because I did not switch all those signs out. So my graph belonged at the bottom. because I need to go through and make everything negatives. Those pluses. So not the green graph, the black graph. Okay, kind of cool. So that's how you set it up. So let's see if we can make the next one better. Going off our cosines. So we're not doing the first graph, we're not doing the second graph. Let's do the cosine. And we're just going to take our answer for our cosine and we're going to double it. I cut something off, but that's okay. So cosine, well, back up. 2 cosine. 2 cosine of 1 will be 2. 2 cosine of pi 6 is 0.86, double that, 0.16074. And then square root, or 1/2, double that, we get 1. We're going to get 0. We're going to get -1. Going to get -1.74. And pi is -2. 7 pi 6 will be -1.7, -1. This is going to be 0, and then we go positive, 1. It's going to be 1. And this is going to be 1.7, and then this will be 2 again. So let's do it. So biggest route, this point here is 0, 2. Whoops, nope, backwards. 2, 0. Okay, so that's our first point. 2, 0. Then we're going to go to pi 6, 1.7. And then we're going to go to 1. Then we're going to go to 0. And then we're going to go to 2/3, -1. So that's over here. And then 5, 6, -1.7 over there. And then pi, we're going to go to -2. So this one here is the same point. And we're just going to find out that we're right there. So let's go to Desmos.com and graph that 2 cosine theta. Yay, I got it right! All right, so that's how you do that. You just use the chart and you can fill it in. It's kind of fun. Also, just you going to Desmos.com is kind of fun too. So let's go on to the next stuff. Okay, so if we see something that's symmetric to the line theta pi halves, that's actually this line here. I did that one wrong. Back up. Okay, that's that line. When we're talking about the polar axis is this one. Okay, and when we're talking with respect to the pole, that would be this. Anyway, there you go. Okay, so use symmetry to graph each equation. So if I have 1 minus cosine theta, we could just create a chart. So if we want to go to our super cool chart, and we're going to minus cosine, so on our super cool chart, if we minus cosine, then everything is going to be minus, right? So I'm going to use that chart. So if I take 1 minus 1, my first dot will be at a 0. And then if I take 1 minus cosine, let's do 30, 1 minus 0.87 would be 0.1 something. What's the biggest we're going to get? 1 minus 0, so this would be 0.8, so let's come here. And let's do pi thirds. 1 minus pi thirds is minus 1/2, so it's going to be 0.5. And then 1 minus that will give us 1. Oh, that looks big. Oh, we can get bigger. We're going to actually end up with 2. Delete that whole thing. So let's make this here 2 comma 0. So that's your 1. So that first dot was 1 minus 1, which is 0. Pi 6 was 1 minus 0.8, so that's just small. And then we're going to go to pi thirds, which is 1/2, 1 minus 1/2, which is still smallish. And then 1 minus 0 is 1. I think I messed up on that dot. And then we're going to come back the other 1 plus 1/2. It's 1.5, which is about here. Oh. And then 1 plus 5, 6. 1.8. And then this one's going to be 2. Now we're just going to use symmetry to finish it out. Cool! Let's go do our graph and see what it looks like. 1 minus cosine theta. Got it! Okay. So that's kind of how you do stuff like that. That one's called a cardioid. Let's just do this graph here in our graphing calculator. So 2 plus cosine. And that's what our lovely graph looks like. It's just kind of cool. Goes out to 3 and all that good stuff. All right, so here's a quick test. It's going to be symmetric if it's a polar axis, and if it's a sine, so if it's cosine, it's polar axis. If it's sine, it's going to be along the this one. If it's this one, it's going to be this one. Okay. So let's go ahead and let's graph our cool stuff. We could talk about symmetries. We can go through and crunch our numbers, but let's just go ahead and graph it. 3 sine, and 2. Super cool. By the way, that's called a rose. Cancel. Let's go ahead and look at some of this stuff. It's just kind of interesting, I think, to look at it. So there's my rose. Let's open the graph. So, oh, well, that's a little weird. Oh, it's just because it's trying to shade it. That's why it has this inequality there. Anyway, it's just shading it. So if I have, let's go ahead and do 9. Let's go ahead and do 1. See how cool that is? Those are my roses. That'd be with 3 theta. That'd be with 2 theta, because 6 divided by 3 is 2. Let's go for 5 theta. There you go. What if we just have 10 theta? Anyway. Oh, let's do an even number. What if we had 8? This is 8. Oh, that's 4. Okay. Yeah. So anyway, just messing around with that stuff. I think it's kind of cool. So let's go ahead and show you what we have those. So because this is 2, we actually have 4 legs. And it's going to go out 3 tick marks. So let's count this as 2, 4, 1, 2, 3. And we're going to go on 45 degrees. That's where they show up. And that's your rose. It's a rose. It's a rose. Let's go look at our cosine one. Our cosine, we have 5 angles. We're going to start well, this is 1, 1 comma 0. Start at 1, but then we got to get to 5s, and that we're going to have 5 parts. I'm just putting guesses in here. I don't really know where they go. They're at 72 degrees different. It's a rose again. And if you don't believe me, then we can go to Desmos and let's graph our thing. I like that though. Let's go to another one. Let's go away. It's not what I want to do. These ones are cool. See, look what happens as I make things bigger. A bigger, make A smaller. Get that's called a limison. Limison. When I get rid of that bump, it's called a cardioid. Anyway, I think it's cool. But let's graph this. So we had cosine 5, and we didn't have anything in front. Yeah, so that was my graph. That's my graph. Okay, I got it right. And then this is just stuff it's in Schoology, so go ahead and read it through. It's just kind of fun to look at things and figure out how to graph them. So let's go find those ones so we can figure out how to graph them. If I have a 9 cosine 2 theta and r squared, 9 cosine 2 theta. So you can kind of see that this would be coming from this graph. So that's what my graph should look like. So it would be square root of 9, so it's going to be 3 out. So we're going to go 1, 2, 3 out, 1, 2, 3 out, and then we've got this. Because we just square rooted that, so it'd be 3. Because that's 3 squared. Okay, so we didn't do that one. And we could do charts and stuff like that, but I think it's more fun. Not fun, funner, it is a word. And then we're just going to look for the one that it looks like. So we have r3 sine 5 theta. So I'm going to be looking at this one because my n is 5, and it says if n is odd, then that's how many petals you have. So that's where we're going to start. We're going to start here, and it's going to be 3 as well, so we're going to be down here. And then I've got to figure out how to get 5 lines on here, so I'm going to put one there. Like, they're 72 degrees apart, by the way. It's hard to tell, but that's where they are. See if I got this right. I might have gotten this one wrong, because I think it actually originates otherwise. So I'm going to use my cool calculator. Back sign. I knew it! I did it wrong. So undo, delete. This one starts up here. So it's going to look like that. Oh, I got it. All right. Anyway, they're kind of weird, kind of strange, but enjoy them. All right, later, Gators.